Hello everyone. So today we will start a new topic, Taylor's and Maclaurian's series, okay? So in this chapter we will study infinite series, especially in the form of power series. And such series expansions are useful to approximate the numerical values for the functions like sin x, log x, e raised to x, etc. And for that we will use Taylor series and Maclaurin series in the powers of some variables. Now you all know what is infinite series. We have already studied in the convergent and divergent series that any given series from 1 to infinity is called infinite series. And you all know the meaning of power series because we already did it in the previous lecture, that whenever if the series is given summation n equal to 0 to infinity cn x minus a raised to n c0 plus c1 x minus a plus c2 x minus a whole square and so on, then we can say that such series are called power series in x minus a. Okay. And if we put a equal to 0 here, then we will get such type of series, and then during that time we can say that such series are called power series in x, okay, because here power of x is varying. So such type of series are called power series, okay. So Taylor's theorem, this theorem is used in the different examples, and you have to remember it without proof. Its proof is not asked, so just remember its theorem, okay. F of x equal to f of a plus x minus a by 1 factorial into f dash a plus x minus a whole square by 2 factorial f double differentiation, or that is f double dash a, and up to it will go till f raised to n and then f raised to n plus 1 form. So this is the Taylor theorem, okay. So this is the first differential, this is second differential, third differential, and it goes up to the nth differential, okay. Then this is called a Taylor theorem with Lagrange form with remainder r and x. Means this is the last term which is n plus 1. જે n plus 1 વાળી term છે એને remainder term કહેવાય, okay. Taylor's theorem ની અંદર જે n plus 1 વાળી term છે એને remainder કહેવાય, okay. So in Taylor's theorem the remainder term will be this. Similarly, if we put a equal to 0, હવે આ જે થિયરમ છે એમાં a equal to 0 પુટ કરી દઈએ બધે તો આપણને શું મળશે? આવું મળશે f of x equal to f of 0 plus x by 1 factorial. અહીંયા a છે જે આ તે આપણે શું પુટ કરવાનું છે? 0, okay. So we will get f of 0 plus x by 1 factorial into f dash of 0, x square by 2 factorial into f double dash of 0, and up to x raised to n by n factorial f raised to n 0 again, and after this term we have this term which is a remainder term again. But whenever you will put a equal to 0, જ્યારે પણ a equal to 0 પુટ કરીએ તો જે આપણને સિરીઝ મળે એ સિરીઝને કઈ કહેવાય? Maclaurian's theorem or Maclaurian's series, okay. So this was the Taylor series and this was your Maclaurin. This is a Taylor theorem and this is a Maclaurin theorem. Whenever we will put a equal to 0, we will get Maclaurin theorem, okay. And again the remainder here is this term. So this is the remainder. Now what is the Taylor series? If f of x possess derivatives of all orders at a, then we have f of x equal to f of a plus x minus a by 1 factorial into f dash a, x minus a whole square by 2 factorial and f double dash a, and so on. But here we don't have to write remainder term, okay. Theorem છે એમાં આપણે દેખાડવા માટે show કર્યું કે here we have this remainder term, but whenever we will solve the examples, Taylor series will be used, and during that time you don't have to write the remainder term, okay. અહીંયા સુધીની જ terms આવશે in the Taylor series, and similarly in the Maclaurin series છે આટલી terms આવશે, okay. So again we will get this Taylor series. And from this Taylor series, we have the two results. That is, the result one is if we replace x by a plus h. આ ટર્મમાં ઇક્વેશન 1 માં x ની જગ્યાએ a plus h put કરીએ તો we will get another form of Taylor series. Okay, then also we will get another form of Taylor series. So if we will put if we will replace x by a plus h here, then this a and this a will get cancelled. Similarly here also. So we will get f of a plus h is equal to f of a plus h by 1 factorial into f dash a plus h square by 2 factorial into f double dash a up to h raised to n by n factorial f raised to n into a. So this is also a Taylor series, but this is the another form of Taylor series we got by replacing x by a plus h. And the another result will be if we will put a equal to 0 in this equation, then we have already studied that if we will put a equal to 0 in the equation 1, then we will get the series called as Maclaurin series. Okay, જ્યારે પણ આમાં આપણે 0 put કરીએ અને જે series મળે એને કઈ series કહેવાય? Maclaurin series. So this is our Maclaurin series. Okay, so this is the main difference between Taylor series and Maclaurin series. They both are same, but in Maclaurin series you have to put a equal to 0. So you will get this series, and that is called Maclaurin series. Expansions of some standard functions. You have to remember these standard functions. Okay, it will be useful in solving examples. Maclaurin series for e raised to x is this. પણ આપણે સોલ્વ કરવું હોય, પ્રૂફ કરવું હોય તો પણ આપણે કરી શકીએ કે મેક્લોરિયન સિરીઝ ફોર e raised to x છે. એટલે મેક્લોરિયન સિરીઝ કઈ છે આપણી પાસે? Formula of Maclaurin series is f of 0 plus f dash of 0 by 1 factorial and so on. So we have f of x. So f of 0 we will get, and we will get all the values up to f raised to nx. And if we will put all these values in the standard formula of Maclaurin series, then we will get the answer. And we will get the Maclaurin series for e raised to x. So e raised to x is equal to 1 plus x by x square by 2 factorial plus x cube by 3 factorial. So you have to remember that Maclaurin series for e raised to x is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Similarly, Maclaurin series for sin x. Then Maclaurin series for sin x is x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus so on. Similarly, for cos x you have to remember the Maclaurin series. So cos x માટે Maclaurin series છે 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus and so on. Similarly, for tan x we have the Maclaurin series, that is x plus x cube by 3 factorial plus 2 by 15 x raised to 5. Okay, so for tan x we have x plus x cube by, it is here 3 only, x plus x cube by 3 plus 2 by 15 x raised to 5 and so on. Similarly, Maclaurin series for cos hx. So cos hx ની formula આપણને ખબર છે, e raised to x plus e raised to minus x by 2. So e raised to x ની value શું છે? 1 plus x square by 2 factorial and so on. E raised to minus x put કરીએ તો here in place of x we have to put minus x. Then we will get e raised to minus x, અને બંનેને એડ કરીને આમાં પુટ કરીએ બંનેની વેલ્યુ e raised to x and e raised to minus x ની, then we will get cos hx, that is 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial and so on. But it will be very lengthy process, so you have to remember these standard expansions. Okay, so you can directly write in the MCQ or whenever in the example if it is used. Okay, so cos hx is 1 plus x square by 2 factorial plus x 4 by 4 factorial. So this is the standard Maclaurin series for cos hx. Then Maclaurin series for sin hx is x plus x cube by 3 factorial plus x5 by 5 factorial and so on. Similarly, Maclaurin series for log 1 plus x is x minus x square by 2 plus x cube by 3 minus x4 by 4 plus so on. અને Maclaurin series for log 1 minus x કીધું હોય તો it will be minus of log 1 plus x. Minus of x, x plus x square by 2 plus x cube by 3 plus x4 by 4. And this is the standard expansion of log 1 minus x and log 1 plus x. Now Maclaurin series for 1 plus x raised to m, where m is any real number and x is less than 1. જેમ કે 1 plus x raised to 2 આપેલું હોય તો ડાયરેક્ટલી આ જે એની ફોર્મ્યુલા છે, આ જે એનું સ્ટાન્ડર્ડ એક્સપાન્શન છે એમાં તમે પુટ કરીને એનો આન્સર લખી શકો. So you have to remember the standard expansion of 1 plus x raised to m, that is 1 plus mx plus m into m minus 1 by 2 factorial into x square plus m into m minus 1 into m minus 2 by x cube by 3 factorial and so on. Now Maclaurin series for sine inverse x. Then its Maclaurin series standard expansion is x plus x cube by 6 plus 3 by 40 x raised to 5. Similarly, for Maclaurin series for cos inverse x and tan inverse x is also given. You have to remember all the standard expansions. And Maclaurin series for tan h inverse x is x plus x cube by 3 plus x raised to 5 by 5 and so on. So there are 13 standard expansions of Maclaurin series which you have to remember. Now moving towards what is Maclaurin polynomial and Taylor polynomial. It is nothing, it is same as which we are using the formula of Maclaurin and Taylor. At x equal to 0, if f is n times differentiable, then its Maclaurin polynomial will be, that is that if we will put x equal to 0, then we will get f of 0 plus f dash of 0x plus f double dash 0 by 2 factorial into x square and up to f raised to n into 0 by n factorial into x raised to n. Okay. Similarly, for Taylor polynomial. So Taylor polynomial will be at x equal to a. If f is n times differentiable, then we will get polynomial x will be f of a plus f dash of a into x minus a plus f double dash a by 2 factorial into x minus a whole square and up to f raised to n into a n factorial x minus a raised to n. Okay. So, and here it is necessary to note that Maclaurin polynomials are special cases of Taylor polynomials. Okay, because Maclaurin polynomial is derived from the Taylor polynomial. કેમ કે જ્યારે ટેલર પોલિનોમિયલમાં આપણે x equal to 0 પુટ કરીએ છીએ ત્યારે આપણને Maclaurin polynomial મળે છે. So we can say that Maclaurin polynomials are special cases of Taylor polynomials. So now let us see the examples of Taylor polynomials and how to find Taylor polynomials and Maclaurin polynomials. So example 1, find the Taylor polynomials for cos x about x equal to pi. So here given function f of x is equal to cos x. Okay. પણ આમાં શું કીધું છે about x equal to pi. So we have as we have to find the Taylor polynomials, we will use this formula of Taylor polynomials. Okay, so we will find f of a, f dash of a, f double dash of a, and first of all we will find all these values and then we will substitute in this equation. So first of all we will find f dash of x. Okay, so f dash of x will be minus sin x. પણ આમાં શું કીધું છે at x equal to pi. So x ની જગ્યાએ શું પુટ કરવાનું હશે pi. So f of pi અહીંયા પણ શું થશે cos pi, that is minus 1, and here also f dash of pi શું થશે 0. Sin pi is 0. Okay, we will find f double dash of x, that is minus cos x, and f double dash of pi, again if we put pi here then we will get 1. We will find the third differential, that is differentiation of minus cos x will be sin x, and that is equal to, if we put the value pi then we will get 0, and differentiating fourth time we will get cos x, and if we will put the value pi here then we will get minus 1. Okay, આમાં કીધું નથી કે કયા ઓર્ડર સુધી કરવાનું છે. ઇન ધ સમ એક્ઝામ્પલ દે વિલ ટેલ ધેટ ડુ અપ ટુ 3, પણ આમાં કીધું નથી. તો ડ્યુરિંગ ધેટ ટાઈમ યુ હેવ ટુ ડિફરન્શિએટ અપ ટુ third or fourth order. Okay, so we have differentiated. Now we will put this all the values in the Taylor polynomial, standard Taylor polynomial. So we will get the Taylor polynomials. So here p and x. First of all, we are writing the first of all we will find the values, that is f of a plus f dash of a into x minus a plus f double dash of a into x minus a whole square by 2 factorial up to the last terms that we will get. Okay, then but here the point given is pi. Okay, so here we have to write f of pi plus f dash of pi into x minus pi plus f double dash. X equal to pi is given, but x is equal to a. According to Taylor polynomial, x ni value a ne pan equal che. So our a is also pi. So here in place of a you have to put pi. So f of pi plus f dash of pi into x minus pi plus f dash of pi by 2 factorial into x minus pi whole square up to f raised to n pi by n factorial into x minus a raised to n. Sorry, here pi. Now if we put value, તો f of pi શું આપણને મળ્યું હતું? -1. તો here we will get -1 plus f dash of pi શું મળ્યું હતું? 0. So this term will be 0. Then f double dash of pi, what we got? F double dash of pi, that is 1. So 1 by 2 factorial into x minus pi whole square plus, what was our third part? Again it was 0. So third factorial will be also, third part function will be also 0. Then f of fourth term is given, f of pi is -1. So here we will get -1 by 4 factorial, and what was the value? 1, and here x minus pi raised to 4 up to, હવે આ ટર્મ્સ કેવી થઈ જાય છે? They are in the alternating form. Okay, minus. So here we can write -1 raised to n plus 1 by 2n factorial. Okay, you can see here that one term is minus, then again plus. This is 0. So minus plus minus plus. So આપણે આવી રીતના લખી શકીએ, એનું સ્ટાન્ડર્ડ ફોર્મ લખવાનું છેલ્લે. So that is -1 raised to n plus 1 by, નીચે શું થતું જાય છે? 2 factorial, 4 factorial. So it will be 2n factorial. Okay, and here we have x minus pi, and અહીંયા શું થાય છે? 2, 4, that is x minus pi raised to 2n. Okay, so this is the standard series which we got after putting the values. This is the standard Taylor polynomials which we got, that is -1 plus 1 by 2 factorial into x minus pi whole square -1, કેમ કે third આમાં છે એ 0 થઈ જાય છે. So we will directly get the fourth term, that is 1 by 4 factorial into x minus pi raised to 4 plus, and at last you have to write the standard form up to nth term. So our nth term will be -1 raised to n plus 1 into x minus pi raised to 2n by 2n factorial. Okay, so in this way you have to find the Taylor polynomials. So let us see the another example. Example 2. Find Taylor polynomial of order 3 for under root x about x equal to 4. So here f of x is given under root x. અને શું કીધું છે? At x equal to 4. So we have to put x equal to 4. So here we will get f of 4 equal to 2. Then our first differential f dash of x will be 1 by 2 under root x, and that will be 1 by 4. Then taking the second derivative, we will get minus 1 by 4 x raised to 3 by 2, and putting 4 here, we will get minus 1 by 32. Similarly, taking third derivative, we will get 3 by 8 into 1 by x raised to 5 by 2, and putting value x equal to 4, we will get 3 by 2, 56. હવે અહીંયા શું કીધું છે કે up to order 3. So we have calculated derivative up to order 3. Okay. અને પહેલામાં ઓર્ડર આપેલો જ નહોતો કે ક્યાં સુધી કરવાનું છે, તો you have to do up to 3 or 4 orders. But here it is given that up to order 3. So we have calculated 3 derivatives up to order 3, and then we will put its values in the standard Taylor polynomial formula. So we will get f of 4 plus x minus 4 into f dash of 4 plus x minus a છે એ શું છે 4 છે. So here in place of a we are writing 4. So x minus 4 whole square f double dash by 4 by 2 factorial and so on. And then putting the values. f of 4 ની value શું મળી હતી 2. So here we will get 2. x minus 4 આમનામ રહેશે. First derivative was 1 by 4. So here we will get 1 by 4. Then second derivative was 1 by 64 and 1 by 32 into 2 factorial. So 1 by 64. And the third derivative was 3 by 256. And into 1 by 3 factorial કરીને solve કરશો તો શું મળશે 1 by 512 into x minus 4 raised to 3. So this was your Taylor polynomial. So example 3. Find the Maclaurin series for the function f of x equal to 1 by under root 4 minus x. So here f of x is given 1 by under root 4 minus x. And now, according to Maclaurin series, if we put f of 0, then we will get 1 by 2. Okay, here we will get 1 by 2. Then derivative, we will take its first derivative f dash of x, and that will be equal to 1 by 2 4 minus x raised to 3 by 2. And then again putting the values, we will get 1 by 16. Similarly, taking the second derivative, we get f double dash of x, that is 3 by 128, and f triple dash of x, that is third derivative, will be 15 by 1024. And now, by Maclaurin series, if we substitute values in the Maclaurin series, then we will get the answer 1 by 2 plus 1 by 16x plus 3 by 256 x square plus 15 by 6144 x cube. Okay. And in the same way you have to find the Maclaurin polynomial. Okay. Taylor polynomial find કરતા હતા એવી રીતના જ Maclaurin polynomial પણ easily find થઈ જશે. But only formula will change. Other steps will remain as it is. Okay. So I have given 4 examples for practicing. That is 2 examples of Taylor polynomials and 2 of Maclaurin polynomials. So do practice these examples. Here you have orders 0, 1, 2 and 3. So you have to find 4 orders, and here a is given 1. So you have to put a equal to 1 here. And here also 1 by x and a is given 2. And then you have to find the Maclaurin polynomials again for order 4, and 10x and x e raised to x is given. Answers are also given, so you can verify whether you got correct answer or not. Thank you everyone. I hope you all liked my video lecture. Thank you.